we are saying if we have the system and we have the Java already set up on our system, then that's great. So if we have the Eclipse, I don't know, do we go by the Eclipse or you want me to switch to use my ordinary notepads that I normally use? But either way, whether Eclipse or whatever. So let's just create a new Java file, create a new Java project. Yeah, I don't know, do you have that with you or should I wait for you to finish? Or can I just proceed? You all take note of the concept and then you implement the same thing. What do you advise?
So our advice would take note of the concept.
Switching to ID is better.
So we don't need to do it like together, right?
Sir, I would say those that can move with you, we do. Everybody will not be able to move with you, sir. So
we'll do
if it's not, then I will not waste time again coming to create user NetBeans, because I know it might be difficult for you to even see. If I create a new project now, let's say create a new project, and I'm sure it might be difficult for you, let's say as example 1. And then let me just leave it as default. This just say finish. So now,
so are you sharing your?
Oh, sorry. Thank you. So I created a new project. Yeah, after I've launched, I created a new project. I call it examples. So here we go. And which I'm sure some of you are very familiar with this, if at all you have ever used Eclipse. It has the SRC where it arranges some of the Java files. So when you check, you will see the kind of organization it has. So it's using a default package called examples, something like this. So if you like, you can now create a new Java file. That is, if you want to create a class, you can create a class here and give the name of the class. Let's see, the name of the class will be, let me say student. It's just the name of the class. And modifiers, is it supposed to be public or abstract, something like that? So you can check. And then the package, can it be default package or you want to specify your own package? So if you want to specify your own package, you go ahead. Otherwise, you use the default one. And if it has inheritance, you can add, if there is any existing class, you can now add that this class is an extension of another class. So I don't want to go into that. I will just leave it as basic since we have not started inheritance. So does this class include public static void main? So let's say this class include public static void main. Let me uncheck this, inherited abstract methods. No, so let me just say finish. So I have the student class already created with basic skeletal. Look at it here. So it's created with basic skeletal with public static void main. So why I want to, this is the material we are following. This is the material we are following for today, will be the lecture 2. That is second chapter, subsection 2. So what is my program doing? So that is what we're going to talk about today before moving on to the next. Now, so what is the objective of today's class? Today, we're going to cover the following objectives. We need to understand how Java is read line by line. So when you write a program, how Java compiler read the statement line by line and execute it. So that is That is what we're going to understand, how Java reads line by line. So where does it start? Does it start from the left or start from the right? Does it start from the bottom or start from the top? So we need to understand that so that whenever we have any issue, for instance, let's say, as usual, we know what is a checkpoint for, let's say, for instance, a military checkpoint or police checkpoints like. So the reason of having a checkpoint is just to ensure that whatever is going to happen between one checkpoint and the other, something must be traced. So if there is any issue, maybe any security breaches that's going to happen, then it should be suspected to be within a particular point. So the same thing, whenever we are writing program and we encounter any issue or we want to debug, we can just start, because Java starts executing from the top to the bottom. Then at a point, we can say, okay, the program should halt, that it should stop at a point. Not necessarily that when it starts, it will not stop until it finishes. So we can say, let it just stop at this point. So this is what we're going to also talk about, set and use breakpoints. So we use a breakpoint to indicate where exactly we want our program to stop. Yes, and then we can also allow it to continue if we want. So now end statement with semicolon. Every statement, just like when we make sentence, we said full stop, period, used to end the sentence. So the same thing in Java, we use a semicolon. You remember, this is a language. It has its own syntactical rules, just like the way we have grammar in any language. So the same thing, we have grammatical rules in any programming language. Yes, this is what makes it to be a programming as a language. So it has its own set of vocabularies, which we're going to study in Principle of Programming Languages. So you now have the feel of all various programming languages and see or try to understand the strengths and weaknesses of every language. But since now we are talking about specifically Java, so we restricted to only Java. Now, how do we organize our code using white spaces and other conventions? So we use the white spaces to organize our code, make it readable for a human. And remember that whatever program you write is not just meant to be for you. It is meant to be for other people also to understand the program and be able to enhance it. So especially when you come to work as a team, you can't just write your own way of coding without following the standard convention. And that's why we have convention, some standard convention. So when you follow the standard convention, whoever sees that, just like, let's say, the name of the class should be noun or non-phrase, and you decide to name your class something different, that you confuse other programmers as well. So, but when we follow the normal convention, that will also going to have anybody who is coming to be part of the team. So how do we organize our code? We use indentation. So indentation also is part of the white spaces, and other conventions like the way we name our classes, name our variables, name our method, and the rest like. And then we create a comments. Comments, so normally we write some documentation, especially when there is very critical logic, and you yourself that want to implement the logic, you might not be able to remember exactly what is happening or what you wanted to do here, but by making it documented, then when next you come, you will be able to understand exactly what you wanted to achieve or what you have achieved. And anybody else who is coming to check your program will also understand based on the comments you made. Comment is not part of what Java is going to execute. It's not part of what Java is going to execute. Yes, just like, sometimes we write on a page and then we go to the footer and write something. So that's what we write at the footer used to describe something that is not part of our main write-off, but rather to just guide others to see some other footnotes, if you like. So the same thing here now in the language, we do that. Now, we say Java reading a program line by line. So it means it's reading line by line. It never just starts here and jump to the other and jump to another line, unless if a directive is given. Remember, you are the one who is controlling the program, you the programmer. So you can decide to say, go here, do something and come back, then continue from here. All the same, you can do that. That is just an instruction. So we need to understand, how do we make this control? How do we transfer the control by writing code. So since it's executing line by line, system.out.println is going to print out this line 1, then next one will be line 2, next one will be line 3, next one will be line 4, next one will be line 5. So all these 5 lines will be printed. But remember, there's no way we see line 2 before line 1. We cannot see line 4 before line 2. We cannot see line 5 before line 3 or 4. So this must be executed in this order. In this order, line 1, then line 2, then line 3, line 4, line 5. So this is how it does. I'm talking about execution, but later we'll see that it is not the order in which we write some time that's determine how the program is going to run. If you remember when we are designing the GUI, you may create something, but then it's not necessary that when you create, then it's going to come first. It depends on the order in which we arrange them into our component, if you can recall. So, and likewise, we can have a method, but the method will be called at a point where we want the method to be executed. But since this one is a direct given instruction, you are saying computer should print out this. Therefore, once this line is encountered, then it must execute before moving on to the next line, like that. So this, of course, when you compile, you see the line 1, line 2, line 3, line 4. So this is why I say line 1 is read, then line 2, then line 3, then line 4, then line 5, in this sequence. Okay, now Java is mostly read line by line, as we have talked, but there is a few additional points to consider. We are going to investigate using the breakpoint, other features of Java IDE. So it means there is something which we're going to see some additional points to consider, which we are going to investigate. How do we make use of breakpoint? Breakpoint is to say, okay, even though it's reading line by line, but we want it to say, okay, after printing line 1, line 2, we want the program to stop. Don't move on to the line 3, line 4, line 5. We want it to stop here, this line 2. So how do we insert a breakpoint there? Or we come to line 4. After line 4, we don't want line 5. Then we can insert a breakpoint. So if there is any error, we can just be moving line by line and realize, oh, this is where the issue. As long as the program cannot jump to the next line, it means the problem is from this line. If we can successfully pass this line, because we are moving line by line, if we can successfully pass this line without any error, and then after this line, we discover that the expected output is not as expected, or there is an error. Maybe it could be a logical error or something like that. But if it is a syntax error, you can't even compile the program, not to talk of running. So, and then we've successfully passed line 1, line 2, line 3. But unfortunately, line 4, we expect maybe, we are not sure, of course, whether line 4 has some logical error or something that we want to trace. But if we can successfully pass line 1, line 2, line 3, and then coming to line 4, we check and discover that there is an anomaly, then we know that the problem is specifically from here. So you see, this will allow us to even debug our program so very easily. So the breakpoints is what we're going to talk about. And that's why I jump in to use the Eclipse. Otherwise, I would have just used my ordinary programmer's notepad so that you can visualize whenever I'm writing any code. I'm sure you can visualize it. This one thing I like this. I can just hold my control, then use the mouse, scroll up and down, then people can see. Don't mind, this is not Java code. If you want to see, this is your Java code. This is Python as well. So, so other features of Java IDE, which also are the things we're going to talk about. Now, how do we set a breakpoint in our code? What is the use of the set code? It says pause code execution. So when program is executed, we want to maybe halt it to pause, let it stop at a point. Okay, now check the current state of the program, because we are moving line by line. So we are checking at every stage, we are checking the state of our program. At every step, we are checking the state of our program. So that will give us an idea that, oh, this is the line that is producing a wrong output. something like that. So this helps us to debug. So at least we have seen the importance of why do we need a breakpoint. We pause execution, check the current status of our program, and also it is to help debugging. Now, debugging means fixing error. That's what we mean by debugging, right? Yeah, fixing any error is what we mean by debugging. Now, breakpoints affect code execution when code is run with the debugger. Yes, so we can enable debugger as well. Debugger allows us to easily debug our whenever there is any issue with, and once we enable debugger, then it can help us fix so very easily. Yes, because a debugger will specifically tells you where the problem is expected to be. So the breakpoint can't affect code execution. When code is run normally, yes. But when code is running normally, then fine. So there is no point of even having the breakpoint. Okay, so how do we set a breakpoint here? Animation. To set a breakpoint, place your cursor over a number line in the left margin. Then click, and you have a breakpoint. Click again to remove the breakpoint. You can set many breakpoints. So meaning, let me go here. Let me copy this system.out.println. I hope it can be copied. So let me go to the Eclipse here. Let me paste this. Okay. So one thing I need to do is to remove the numbers here. So if you check carefully, here now, we have all the breakpoints. So let's say we run this without having enabling the breakpoints. Let's check. Module example not found. Which is the module example. Run the file. Just a moment. Anyway, let me. Public class students and should run for anyway. Let me just see something here. Let's say new. Use execution GLE, create separate folder for source file, use project folder as root of the source, create module, and so this guy should go. So let me just go with example 2. This guy, let me say this guy should go. So let me create a class. Now the class should be student. It's a public class, and it has this. Okay. Then repeat the same thing. Okay. Again. So that means my something here is, I don't know why it's not loading. And I really want to, anyway, but only when I come to run that we can see the use of these breakpoints. Because there is already an application. Application 1 is taking it as default. So one thing I can't remember precisely where to change the defaults so that it should be able to locate to see this, not the old one. defaults project workspace. So this factor is this organized imports of this.
So for now, can we use Notepad++?
Anyway, so I don't think I have the Notepad++. I don't think I have that one. Recent file, no. There is one configuration that you change, because I changed the default one to show that application one. So there is somewhere you can change the default one. That is the problem with this. So each time you come, it's going to be pointing to the same application. That is why when I click on this run, then it's showing application one as default, which is not seeing this particular one, but I have a project one application already. So there is somewhere, because I don't frequently use this Eclipse, so I can't remember precisely where to change this. Anyway, if it's going to take much of our time, then we have no choice. Anyway, so I think if this will not work, let me see. No, it's still the same, because it's saying run as. And even I see just run, then we just run this particular one. But only run as. External tools. Okay, so all we are saying that if we want to enable the breakpoint, this is the breakpoint. When you click, then this becomes the breakpoint. When you click here at the edge here, so you now have the breakpoint here, or you can use the menu up there to insert the breakpoint. So where we have the line numbers here, this is where we set the breakpoint. And when you click again, you remove the breakpoint. So I think if this will not allow us to move, but I think I will switch to my programmer's Notepad. Later, when I still go through this, then I find the easiest way, then we can be using this, because my thinking is, since the material is based on using the Eclipse and some NetBeans as well. So I was thinking we can make use of this. So things like that. So you can use a short commands to toggle the breakpoints. So let me just, since I believe you understand what you mean by a breakpoint. When you write this line of code and you say you want to enable breakpoint here, then the program will continue to execute until where there is a breakpoint. Then it will stop. Yes. So once it stops there, you can check from here to here, is there anything wrong? Then if there's nothing wrong, then you can now remove the breakpoint and then move on to the next until you are done. So that will also help us to understand where exactly the problem is occurring. So that is the work of the breakpoint. So that is what we wanted to enable. And look at it here. This is the breakpoint. This is another breakpoint. We have 3 breakpoints here. So from here now, everything will run until where there's a breakpoint. And again, from this to this, it will continue to go. And then from this to this, it will continue to go. So if there is any issue, at least within from here to here, you'll be able to realize that, oh, the issue is coming from here now. So that is the use of the breakpoint. So of course, this is the plus button to create a new project and add this file to the project. Set a breakpoint at line 5 and align with the first print statement. That is it. Now run the program normally. Breakpoint should have no effect. It's not going to change any output, just to be able to allow us to debug. So again, these are exercises. Run the program with the debugger. Make sure that the output window is showing. Press tab over to go to the next line. So that is when you enable debugger, you can move on to the next line. That's when you are here, it will move next, and then you'll be checking. So not that necessarily that's like the way we set a breakpoint, only that, okay, it will start and wherever there is a breakpoint, then it will stop. But debugger will allow you now to move, to click on next, and of course, observing where the issue is coming. So that is the work of the debugger. So make sure that the output window is showing. If you check here now, even here we have the output window. This is it. Oh, this one down here, because this one organizes our codes to see the hierarchy. But down here we see the output, if any. Okay. So I think for this, if we can proceed, let me move on to take this to the, okay, let me just make use of this, no issue. Now, so this one is saying, how do we investigation results, part 1. You could say Java reads code line by line, but if multiple statements are on a single line, it is more accurate to say Java reads statement by statements. So meaning if we say line by line, it's possible that we can have 2 statements in a single line. Like I can have this and then continue to do this. So now if I have this, will this now going to work? Let me remove the arguments. Let me just say hello. Then another one. Yeah, hello. So would this now going to work? If I have this. Any response from your side? Can this program going to work? Yes, are we inside?
Yes, sir.
So will this program going to work if I have this
Yes, sir.
2 print
It's going to
statement on the
work.
same line?
Yes, sir. It's
Okay.
going to work.
Okay. So it means if we say line by line, rather than saying line by line now, even though we know it's line by line, but rather to say line by line, we say statement by statement. Because as far as this is concerned, there are 2 statements here. It's not just 1 statement. And each statement is end with semicolon. And that's why, because of this semicolon, this statement has ended. And then another one began. And this same thing can work for us, so without any issue. So if I say now, hello, Java, or Java, so see, there will be no any issue on tackling with this. So we see our output, hello, hello. See, hello, the first print statement brings hello. The second print statement brings hello. So that's why we have hello, hello. And we can write them on the separate line, or the same, will give us the same result. It's not that the two will be on a separate line, unless we have the print line. When we have the print line, then this will be on the separate line, the other one will be on the separate line. But as far as this is concerned, they will all be on the same line. It's not because we have multiple lines or each of them is on the separate line, then the output will be on the same, on a separate line. They will all be on the same line. See, hello, hello. But to make it more readable to the user, it's better to write each statement on a single line, each statement, rather than combining two statements. So now the semicolon is required to end statements. Remember, statements in this case is like a sentence in English, or sentence is any language. You write a sentence and end sentence with what? Semicolon, sorry, with a period, that's full stop. The same in Java, you end your statement with semicolon. This semicolon indicates the end of this statement, and statement is the same as sentence. So editing code has no effect while the program is running. So you must recompile for changes to take effect. And that is why when I modify this, I have to recompile before I now see the changes. So this is what this is telling us, that each time you modify the code, then you have to compile before you see the changes take effect. So, and then what about the white spaces? If we have the white spaces, does Java preserve the white spaces? So now it says Java is not precise about white spaces. Other language like Python may be extremely precise. So you should write an entire program in a single line. But this is a messy and almost impossible to work with that. So use white spaces to keep code organized. This is one of the reasons why we said, okay, let's have white spaces. You see, if I want, I can take this up here. I can write everything on the same line. It's still going to work. But what is going to happen? You see, even by writing, it's difficult for you to even understand the code. So, but still, it's still fine. It's going to work. As far as that's concerned, you see, it's still working the same thing. But of course, it's very difficult for someone to understand, to make sense out of all this. But if it is well written, space preserved, everything, then it looks good, neat, and easy for anybody to come and look at the program and understand what exactly is there. So please organize your code. That's why sometimes, in fact, most of the times when I write code, you see a kind of indentation. So when you see a public static void main here, public class something, so the closing of this should look when you look down straight, you should see the closing of that. And when you look at this, you see the closing. Yes, so if there is any other one, you see directly when you check, you see the closing. And in fact, with the kind of style this one has, you see a line here indicating it has seen the end of the public static void main. So please, same thing, follow that to organize your code. This is why it says this code works, but it's super messy. Super messy, because you see, it's somehow very scattered. these two lines of statement written on the same line, and then coming here to write this again with some spaces and things like that. So this is still good, but very messy. So it's not a good practice. So white spaces is any space without code. That is what we mean by white space. You keep on having the space without any code there. So, or we can have a blank line also. It's also a white space, or indentation before a line of code. Just like, you know, see, if you look at this, you see an indentation here. You see an indentation, which also improve the readability. So you see here now, the indentation. So if I'm going to have something here, rather than to come, let's say if I'm going to have something here, rather than to start from here, you see, let's say I have system.out.print line. So this is totally bad to write something here now. So it's better to shift, to indent it, align it with this. Yes, align it with this. So later we see within the public static void main, if we have any block statements, so we can also indent it and then write our code within, so that the user can easily understand, or you that you are writing the program, you can easily understand what you are writing. So that is why we said prevent readability difficulties, prevent mistakes while programming. When there is a mistake, you might not be able to see it because everything is written on the same line, or there is no any indentation. It's difficult to debug. And I'm sure for some of you who are writing programs, you understand better. But even if you have never written a single line of code, from the way we have written this now, if I'm to take this all and put them on the same line, you know how difficult it is for someone. If there is any mistake, let's say omission of semicolon, you may not be able to visualize that, oh, there is omission of semicolon here. If I have all this on the same line, imagine this, like that. So when there is omission of semicolon, you might not be able to see it clearly. See? So unless at this point I need semicolon, but imagine you come to check this, you just be scrolling. You might not be able to see that, oh, there is supposed to be a semicolon here because of lack of indentation. So please indent your code, make it neat, and you will appreciate that. So indentation using curly braces, the number of indentation pole spaces and things like that. These are all the spaces we preserve. Okay, so I'm giving an example of that. So we create a new project file to the project. Can you fix this program and produce the following output? Please check under your every exercises here. You will see is there on your dashboard on the Oracle accounts. Please, if you check there are exercises, take exercise 1, take exercise 2. It's very simple, straightforward. The program is there, only that they're asking you how to fix it. So they say create new project and add this. So that means in the project, you are expected to add this text2.java. That is a text2.java there. So if you check on the slide here, and I believe you all have it on your dashboard, so no need of me to share these resources since you all have it. Code files. This is chapter 2. Yes, so you see text1.java, text2.java, text3.java. So all the programs, when they make reference, they know that it is there for you. Just try to load it and then check to see. So can you fix this program and produce the following output? So let's go and take this exercise 2. Let's see what is there, exercise 0.2. So this is it. Now, so this is it now. So they said, can we fix this to produce this line? 1, 2, 3, and 4. So can you fix this program and produce the following output? So who can tell us what do we need to do here to produce such output? Is there anything wrong with this? Is there anything wrong with the program first before we move on to indentation issue? Okay. So
Yes.
okay, what is wrong with the program?
The printout too, I can't really see the line number. Does not have
No,
a
line number is
semicolon.
not. The line number here is from the IDE, which can be toggled. So it's
Oh
not.
yes. So
it's
line
not too good.
6. Line
Okay,
6.
okay. You mean the line number in order for you to make reference to it?
Yes,
Right?
reference so
Okay.
that it will be easy. Line
Okay.
6.
It's okay. So this thing is covering. Let me put the line numbers. So you can see the line number, right? Okay. So now line what?
Line 6.
Line 6. Okay. What is wrong with line 6?
So
I guess statement terminated.
so
Like
I know.
they did not terminate it.
I think
Okay. Oh, I think it's on the. It's okay. Let me copy. Let me go online compiler. Okay, so we are there now. You say semicolon is required here, right? Line 6. Okay, so 1, I fix it. Then anyone? Somebody wanted to talk.
yeah, that's it. That's
Is that the only error?
Yes, sir.
No, line 5, line 7, line 8
Uh-huh.
supposed not to be there. 4,
Yes.
7, 9, something like that.
Yes, so line 5, that is curly braces, and this is not a block of statement, it's just a line of statements, and therefore this bracket is useless. It's only when we have block of statement like this now, public static statement that is meant to accommodate all of this. So therefore we need to tell the beginning and end of it, which is this. And this end here, this is it. So this bracket, this and this are just not needed. No need of having them. So line 5, this should go. Let me just remove it without. Okay, it's auto collapsing. Is okay. Now I remove this one also. I remove this one also. So is there anything wrong now? Is there anything wrong? The only thing to do is just to improve the readability. So let's align them, isn't it? Align them, indent them clearly. So we go, run. So we have the lines 1, 2, 3, 4. So let's restore it back to where it was. Let's run and see the error.
So even with the using curly bracket, it will run.
Okay, with the curly bracket, it will run.
Yeah, I tried it and it worked.
Okay, okay, fine. So another knowledge. Thank you. So semicolon here. We put semicolon here.
Run it to run. But it's run here.
No, let's see. We put a semicolon here and we said that is the initial something. So print line. Anyway, so I don't know the kind of IDE you are using. Anyway, space here.
The online compiler and it works.
You are using the online compiler?
I used the online compiler, exactly this online compiler, and it worked.
And This is wonderful. Anyway, so I don't know how your own work and this will not work. And from the way I know the syntax, if this bracket is gone, this one is gone, then indentation is not important, only to improve the readability. So you see now the error has reduced. So let's remove this. This is the expected one. Then if it works, then fine. You see? So, and I don't know, are you sure you are running the right one,
Yes, sir.
gentlemen?
Yes, sir.
It's okay. So I don't know how that is possible, but if not, because of the time, we will have just say maybe share your screen and show us. But nevertheless, let's everybody try that, because I don't know. Anyway, let's come back to this and see. Some Java commands require curly braces, although you can always add more. Okay, so I think they talk about the possibility here. Color codes the scope of the block. Yes. Automatically indents flowing a curly braces. Highlight a matching curly brace. Yes. Highlighting a matching, that means when I put this, you see, I put this one now, is saying this is the end of it. I put this, is saying this is the end of it. So this is what we mean by highlighting the color. So you see, as I point to this, it shows blue and automatically shows blue here. That means this and this. Yes. Okay, so going by that, so please take your time, try highlight a matching curly braces. Some Java commands require curly braces, although you can always add more. So like this one now and this. So let's still go back to this. Let's see, let's have this one here. Let's have this one here. So let's see. Yes, so I think you are still right. It works with the curly braces. Yes. So maybe there was no matching. We have maybe 3. So if there is no matching, then definitely this will cause an error. Yes. This will cause an error because there is no matching. Okay. All right. So here we go. We fix it. That means, so please take exercise 1, you see, exercise 2. If you can just open this and fix the issue. So this will now help you to be able to debug any program. So if you see an error, don't be panic. Just calm down, check line by line. You'll be able to realize that, oh, semicolon is missing here. This one start here, this one end here. Oh, okay, there is something wrong. Okay, there is something wrong. That will be able to guide you. So you see, all we need to remove now is just this bracket here now. This is an additional one. So this is, I cannot edit from here because I open from a zip file. Okay, so I think let's move on. Then line of comments. Neatly spaced program can grow large and becomes difficult to read. So when you have a very long line, difficult to read, so it's better to make it short. You can add comments to code, provide explanation or additional information to the programmer commenting the code. Remember, you're not the only person who may likely going to continue to work on the project. So you need to document it, as in write some additional information that will guide you for any logic. Let's say now, you see, this is a Python, but again, you can write a comment to say, oh, plot match versus literal bits, something like that. So this is not part of what the compiler will execute. It is not part of. The same thing here, we know we write a comment, it's the same, but this one now using what? // means line of comment. So I can say now printing the hello. Something like that. So when you compile, remember that this is not what you're going to see as an output. It's just to tell us that what are we doing on this line? So we are printing. Just like, you know, when I ask you to do this project, where there is a withdraw method, so you can now say, this is a method that handles what? Withdrawal of only positive amount. Let's say, for instance, positive. So just document it, and if there is any condition, you are right, then you make sure that the condition is written and people can, or when next you come, at least you'll be able to see. So if there is a method called withdraw, at least you'll be able to understand that this is it. Then you specify possibly, let's say, the amount like this. So you can check the logic. So you see the bracket now opens and ends here, which means the beginning of this method, and this is the end of it. So whatever you're going to write that is going to be executed. Must be, somebody please, I think you have opened two devices and it's equally. So you can write the logic here. You can write the logic within the withdraw method. So whatever you want to write, but what tells that this is a withdraw method and this is what it does, everything will be written here. So if you want to have a one line of comment, you make it /. But if you want a multiple lines of comment, let's say you continue to write and it's a long something, so you can just have it here. So within this, you can break a line, because it's not easy to continue writing the comments on the same line. Sometimes when the comment is very long, it might be difficult. So this is why we have a multiple lines of comments. So you can come down and continue writing the condition. And I'm sure if you check most of the well-written program, you will see a comment like this, continue like that, continue describing what exactly all the necessary condition and all the necessary whatever will be written here, and then the implementation will come. So when next you come, at least you'll be able to remember the condition that, oh, for someone to withdraw must have this and this and that. Then the written something, just document it. But remember, it's not part of the program. It's not part of what the compiler is going to execute, because once it sees this, it's going to skip it. But for you to properly document it, then you need to have this one single / and then asterisk. Then you end with */. I believe that is okay, right, guys? So this is for a single line. Start with 2 slashes and end with the line ends. So this is like this one now. A single line comment automatically ends when the line ends. So this is when the line ends, then that ends. But when you break down and come down here to continue, then it's not part of the comment. So this is a single line comment. So for multiple lines comment, this is what I've just demonstrated using this and this. So whatever you write within this. This is the beginning, this is the end of it, like this one now. A multi-line comment continues for every line, system.out line, and this. So everything here is part of the comment. So that's that. Reading line by line, we can do the little more investigating when we look at code blocks. You know, code blocks, we use curly braces to indicate the code blocks, beginning and end. Then comment, breakpoints, other features of IDE. So exercise 3, please, you check there, you find exercise 3, create a project and add this file, then set a breakpoint at line 11, run the program with the debugger. show to have the outputs window selected. Press step over to go to each line. So when you say step over, like I said, we'll be executing line. Then when you say step over, we'll move on to the next line, we'll move on to the next line. So I believe by next, I will make sure that this thing is resolved, where it's showing the default project to execute is no longer this active one. So I will get it resolved. So even when next we want to maintain this, we can maintain it. You see, I wanted to demonstrate these breakpoints and the rest, but it's not seeing this project that I've created as the most recent. But somewhere here, I know it's somewhere where you can change the default. Yes.
Hello, sir.
Yes, I'm with you.
Yes, I think you should put the package at the top, it will run.
Put the package at what?
At the top, on line 1. You just put package and put the name of the package.
Okay, so let's see example 1 or example 2.
Example 2, starting with capital letter, but then you started with capital letter.
You mean this one?
Could you expand it? Yes, open the source.
You mean this E with capital letter? Open the source, okay.
No, SRC. Okay. So that default package, the name was not stated, and that's why it's not running.
This default package?
Yes, the default package. Could you just give it a name and include it? It will work.
Anyway, so let's see if we can rename it. But I want to be very sure that that is not the issue, because if you look at when you come to run, it's not showing this particular example as the default selected program. So I set it off to show that Java application 1. But the default package is must not be specified, because if you don't want to use a package, you can just leave it. So it's going to use the default package. But if you want to have the default package, if you want to have any package, then you can set it up when creating the new project, which basically is from here now. When you said new project, Java
I'm actually
project.
I'm using
Yeah, isn't the Eclipse?
Yes, sir, and it's working. The same code.
Yeah, I'm not doubting that it's going to work, but let me show you what thing I'm talking about now. Let's create a new one with that. Okay, now let's go. Let's say example, this project is example 3. Okay, so I'm sure this is what you have selected, right? Default.
Yes, that's project name. Okay.
Okay, so now, how about this? Project layout is the same, right?
Separate folder is fine.
Okay, so can we move next?
Yes, sir.
Okay, fine. So add output folder to this. So after this now, it's no longer going to be, this is the final stage.
Yes,
this is the final
choose
stage.
source.
Sorry? Choose this, right? And say okay?
Yes, sir. Yes, sir.
Okay. So let me copy this class. Then come here. Let me see, add a class.
No, add a package.
Okay. So maybe that is what we missed. So let's say add a package, right? So let's say example.
Maybe
example 3.
Okay, sir.
Okay. Is that okay?
Yes, sir.
Now what next?
No, you right-click the package. Add a class.
Add a class. Okay.
Class.
Then student, right? Let's say student. Okay, so what next? You select the public static void main.
That's fine.
Okay. Is that all?
Yes, sir.
Okay, fine. So let me just take this system.out.println. Hello. So you see the kind of things I'm talking about now. Somewhere in the settings, I set this to be my default Java application that always going to run. So one thing position to change that is what I cannot remember. Because this is not different from the only thing I think that is different from the way I created this is by specifying the package, and specifying the package must not be necessary. Specifying the package, if you don't specify, it will be on the default package, which is okay. Remember when we talk about package, we say we have default package, and you can also, if you don't specify, it will be on the default package. If you specify, then it will be in that package. And that's why when you compile this program, then the .class extension will be in example package. So, but the problem now is knowing exactly where, because I've changed the setting myself. So the only thing I can't, I have to check every one of this to change the defaults of that to show. So whenever I click on run, it should be able to run my current project, not any other project. I don't know. Let's see, none of this is.
So you should check your JRE.
It's okay. I will check that. I will check. I will make sure that is. I know I've changed the settings somewhere, but it's not a lot of things here. Anyway, let's proceed. So this is why it's not running from my side here. I believe it's not because of the package. Okay. So please go through the exercise 3. So the summary is common mistakes. What are the common mistakes? Missing semicolon. In most cases, we write program and forget to put semicolon at the end. And again, we write mismatched curly braces. We write curly braces, but without ending. This is also a common issue. So again, keep our code organized using white spaces, curly braces, and comments. Yes. So this is for this. We have taken much time on this, so but let's see if we can move to the next slide here. This is what we just finished, I think. I believe this is what we just finished. 2.2. Yes. This is the one we finished. So 2.3 now. So introductions to object-oriented programming. Basically, so if we understand the basic structure, now, so how do we now look at it from the object concept? So the objective of this will be like to differentiate between procedural and object-oriented programming, which in most cases, the program we write are procedural. Can you give me one procedural programming? Even though you remember that even the Java itself can support the procedural. But can you tell me any programming language that you can remember that is a procedural language? Yes. Is C programming a procedural or object-oriented? C. So we don't know. Anyway, so C is a procedural programming language. So we have, sometimes we call it imperative programming language. Now understand a class as a blueprint of an object, because the foundation of everything lies within object. And this group of objects that are related form a class. So to understand a class, we use to create instance of an object. That is, if we have, like, for instance, we have a class called student. To indicate that this object belongs to the student class, this is what we call instantiation. So we instantiate, meaning we create the object that belongs to that class. So how do we create this? We're going to see that. Then we model object as a combination of what? Properties and behaviors. So these are the two things that are very, very important. Properties and behaviors. Let's say the properties of students. Can you give me some of the properties of students? Data fields, meaning attributes like name, gender, registration number. What else?
Matric number.
Yes, matric number. So those are the data fields. We call them properties. So can you give me one behavior of students, which we call methods? When we say behavior, we are talking about methods. So understand that what is the behavior? Whatever you can think of that a student can do is what we call behavior. And that is what we call method, which is different from his name, his email, his phone number, his date of birth, his whatever, all those data fields is different. But now we're talking about his own behavior, being a student. Remember, being a student. So can you give me like 3 different behaviors of students? Who can give me any behavior you can think of? I said behavior, you know, the behavior where we can all behave as humans. So what can you say about the behaviors specific to student?
Student can write exam.
Student can write, can read, can sleep, right? Can do assignments, can
Yes,
ask
sir.
questions, can make noise, can all that. So those are the behaviors. So we look at them as methods. But how to define them is what we're going to talk about now. So it means whenever you consider an object, the next thing to talk of is what? The data fields, which are the properties, and the behavior of that object. Because this is what makes life. And this is what differentiate our data field differentiate between me and you. But the behavior is, that is what will establish a kind of communication between us. We send messages through what? Through behavior, through methods. Through method. And that is why within you and the bank, you perform transaction, withdraw, deposit, and whatever. So those are the methods. The withdraw, deposit, transfer, check balance, those are the method, those are the behavior of the customer in the bank. Because when customer comes, these are the things he's expected to do. But what are the data fields of the customer? His account number, his phone number, his email, and all those things are the attribute that we call them attribute or properties. But behaviors, what customer will do when he comes to the bank, those are the behavior, isn't it? So I hope now, guys, you understand the difference between properties and behavior. Because if right now you cannot differentiate between properties and behavior, then we're going to have an issue. Then later, the next thing to do is to create instance of an object, meaning instance of a class. How do we create to say this is a customer in this bank? So when we say this is a customer, then the next thing to tell is this customer, what are his properties? Meaning what are the name, email, phone number, and the rest like. So we need to mention all those that are possible to say these are the properties of this customer. Then the next is to behavior. How can this customer be able to transact, be able to make deposit, transfer, withdraw? And that's only going to affect his own account. Unless if you make a transfer, then that transfer will be from his own account to another person's account. So that is that. Now, so far we have taken a decade of computer science, innovation, something. So just a review. As much like internet, we have a mate car. Now, the procedural languages, read line at a time. The C language is procedural. So the C, C is a programming language. So it's a procedural programming language because it's read line at a time. So you cannot transfer the control like maybe at an object, at the level of object to say, oh, this is an object, is going to do this. Whatever you write it will start and then continue to execute. And it does not mean it doesn't have functions. It has functions. It can have some functions, but whatever it is there, it doesn't tie to an object. So you cannot say this is the object that is doing this work. But in the object-oriented programming, read one line at a time, yes. Model object through code, yes. So this is what makes it to be an object-oriented. Model object through code. So if I want to say every one of you in this class who is attending this lecture will be treated as an object. So I will create every one of you to be part of my class. But unlike in C programming, I cannot model you to say this is you, this is this, this is this, this is this, as the way you are now. I cannot model that. But in object-oriented concept, I will model each of you now to be an object of the student class. So if you have another class like maybe, let's say instructor, like the way I'm now in the class, maybe giving or teaching, then how can we interact? And this is the way we are interacting. So the teaching I'm doing now is a behavior of instructor, which is typically, is a behavior. And that is a function of the instructor to teach. But who am I teaching? I'm teaching students. So I'm passing to students. Who are the students? Then we need to create them. That creation is what we mean by an instance. So emphasize object interaction. So this is the interaction we are talking about now. So if there is no interaction between one object and another, then there is no point of saying we go for object-oriented if there is no interaction. The main purpose is to allow two objects or more to interact with one another. And that's what makes the transfer so very easy, make deposits, because two objects will be modeled. So imagine if you want to make use of C programming to develop a banking system, then that may be difficult or almost impossible to model as a level of objects. Because how can you transfer between one account and the other if you cannot treat two objects as separate? So that is the interaction. I'm a customer in the bank and I want to transfer money to my friend or to another account. So that is the interaction. And that can only be possible if we allow this to happen. That is creation of objects. So allow interaction without a prescribed order. So we don't need to say, oh, this must be in this order. No, we can create the object and allow the interaction without any order that is mandatory to follow. So Java and C++ are object-oriented languages. So don't forget that's why they have a kind of even similarity. The C++, it has some similarity with Java. It uses semicolon. When you look at the conditional statement, the control structures, so many things that are a kind of similarity. Sometimes when you are writing, you feel like it's as if you are just writing Java. But it has the way like system.out line, this one is using cout, something like that. So object-oriented programming, interaction of objects, no prescribed order, meaning, you see, this is an object, main object here. This one will interact with this and can also interact with this. And this can interact with this and can interact with this. And this interact with this can interact with this. So there is no any prescribed order that's, oh, it must start from here and go like this and go like this. No, it can be in any order. So this is the interaction. So this guy wants to transfer money to this guy, and this guy wants to transfer money to this guy wants to transfer money, and things like that. So it must not be in this order, and this guy can transfer to this guy like that. So this is why we said it must not follow any order, any sequence must not be. So read line at a time. That is for, okay, I think, oh, we are going back. So you check the exercise 1, consider the following. What objects do you find on the field of play? What happens when you put a triangle wall or simple wall icon on the blue wheel? So one most important is to be able to understand, to identify objects. Can we, when we see something, can we identify that this is an object? So that is also very important. But anyway, if you go, we'll be able to understand and figure out how can we identify that this is an object. So play a set of puzzles, become familiar with the game mechanics, consider question as you play, listen to the lessons, debriefing on what you have observed, apply your observation to understand Java concept. Okay, good. Now we are here now. How do we identify an object type? What object did you find on the field of play? This is an object, and this object is a ball. This is a dog. Level geometry, red bumper, blue bumper. So all these are different objects. All these are different objects. So later, like we say, if we identify the object, how do we construct to say this is an object, this is a ball, this is a ball, this is a dog, this is level geometry, red bumper and blue bumper. How do we identify? So now, interaction of objects. There is a ball here, can interact with this. Let's take a closer look at this object here now. And again, from here now can interact with this. From here can interact with this. From here can interact. So there is no, what all we are emphasizing here, there is no any logical order that's okay. This must interact with this first, then go in here. This can be in any order and can make the interaction next smoothly. Just like now the way we are. When there is an interaction between you as a student in the class, there must not be any order saying that Victor must talk to Amina before Amina talk to Omar. So that way, that kind of interaction can come in any order. As long as we said the object has been created, then the interaction can be established. So what happens when you put a triangle wall or simple wall icon on a blue wheel? This is it now. A wall appears on every instance of a blue bumper object. Walls give bumpers behaviors that deflect and interact with the ball. All blue bumper instances share these same behaviors. So that means they can be in the same class when they share the same behaviors. So remember that all this is for us now to understand how we can model a class. So if you see a class, we'll be able to understand that this is a class and these are properties, these are behaviors. So when we identify that this is a class, blue bumper, then the next is to understand what are the properties of the bumper. So the color, shape, X position, Y position. These are properties. These are properties of every blue bumper, which is this. Now, what is the behavior? What is the function, so per se? If you like, you can say, what is the function of the blue bumper? Make pin sound, flash, deflect ball, via triangle or simple wall. Okay? So I hope you understand, you know what the blue bumper here. You take a ball, hit it, let it beat a wall or a triangle like that. So that is the work of it, and you can use this to for flash. You can make pin sound and things like. So these are the behaviors of the blue bumper, and this is the color. Sorry, the properties. So if this is a property and this is a behavior, how do you define the properties? So by the time we go and see how we can define the properties, then that will also make it easier. Remember that the data type we'll talk about, the data type will now allow us to define or to use any appropriate data type to define each of these now. So I think let's rush this to finish this, then we'll stop. And I believe by tomorrow, we'll begin to write the serious code line. So I think if we go by this, the properties of the, let's say we have a cat here. What are the properties? Name, age, breed, favorite foods. So these are some of the properties. And then for the behavior, make mew sounds, play, wash, eat, hunt. So these are the behaviors of what? So remember, when we later on, when we come, we now make this one to be what? Method. Method. Yes, method means behavior. Behavior of what? Cat. And cat is an object. So when we come to model, we now know what is the name of the cat, what is the age, what is the breed, what is the favorite food. So you see, so this is the way it is modeled now. Class and instances. The combination of properties and behaviors is called a class. So when you combine the properties and behaviors, then it becomes a what? A class. Now, these are three different cats, but all can be an instance of objects. They all belong to the cat class. Yes, regardless whether blue cat, yellow cat, whatever cats, whatever the name, whatever the age, is a cat. So a cat is a cat, so therefore belongs to a cat class. And that is why we say, okay, cat class. So we define the class, cat as a class. So remember that the object we are talking about. That's why we say a blueprint or recipe for an object. We used to create object instances. So that is the class. We use the class to create objects. So this is for the notation to indicate this is a property. This is a behavior, which is a method. Now going further, creating new instance from a blueprint. We have a cat here, a class cat. We have the properties. These are the properties: name, age, and favorite food. Remember, as we have discussed earlier. Then we now come here and say the behavior. The behavior of every cat is to make sounds, mew sound, play, and eat. So we consider just three, as you can add as many as possible. So these are the behaviors. Now, we now go into creating an instance. As far as this is concerned, it's generic. It's not specific. We said class cat. But where is the cat? So here now we specify that this is a cat. The cat belongs to the class cat. And what is the name of the cat? Remember, we said this is the order now. Name, age, and favorite. So name means opal is the name of this cat. Age is 11. Favorite food is mice. So you see, we have defined this cat now. Specifically, we have defined this cat with the properties. And then the second cat also is called tiger, and the age is 15. And the favorite food is what? Blue jay. So what is the name of the cat 3 here, please? What is the name of cat 3 based on what we have deduced from these two?
Misty.
Okay, Misty, and then the age of this is what? The age of this cat?
It's 5.
5.
5. Okay, and the favorite food is chicken. Okay, so this is typically, now as far as this is concerned, we have 3 instances. We say we have 3 instances of cat. Remember when we asked you to write a program, By the time you write all the necessary properties, the method and behavior, the properties and methods, we said to create a test class, create 5 or 2 or 3 or any number of instances. So this is the instances now. Specifically to say this is an opal, this is the name of this cat, this is the age, this is the favorite food. So at that point in time, we know the cat we are talking about. But while we are here, we are looking at it from the generic term. Cat is cat. We don't know what is the specific cat. Just like I said, a student is a student, but we don't know which student specifically. But by the time I give the name, the age, and ID of the student, we know the student we are talking about. So how do we construct that to say this is the student? That is what you call instance. So this is why we say creating new instances from a blueprint, meaning from a class. So the class is a cat. We create the instances, mean create the objects that belongs to that class. So please, you should be familiar with this terminology, so all cat instances share abilities to mew, play, and cat and eat. Yes, and eat. So meaning they all have the same behavior. Every cat here, if any of these cat has no any of this behavior, then it's not supposed to be in that class. Maybe we can look at possibility of creating another class that the set of group of objects share the same function or behavior. So we said they all share the ability to mew, play, and eat, meaning every cat here play, mew, and eat. And that is why they belong to the same class. So how do we write program that achieve this level of flexibility? So that is when you have an idea or requirements for a program, you consider what type of objects may exist in this program. Consider the properties and behaviors of these object types. Consider how objects interact. So you see the interaction also is very important, how objects can interact. And how do you identify the properties and behaviors of these object types? Just like a cat now, what are the properties of cat? Behaviors of cat. Then. So, and then what type of objects may exist in the program? So when you have a program, you need to identify first, you need to identify the object. So when you identify the object, that will make you to formulate to form a class. Because based on the behavior of objects, you form a class. Okay, so I think I wanted not to take this time, but we are still within the 2 hours, I think. So this is an online shopping, Duke's Choice online shopping. So these are different items here to purchase. This is the shopping cart. You go and check out here and then whatever, calculate and then put it and take it, go. So you need to understand this process. What do you have each of this now? So you can look at it as shopping cart as a class. And then what are the items in the shopping cart? What are the things that are selling there? So what is the behavior we can identify within the shopping? So objects are physical or conceptual. The object is something which we can see or we can conceptualize. Yes, either way. So objects have properties like size, price, and color. The guys looking at that shopping cart, we can look at the size, price, and color. These are the properties of the objects we have in the shopping. So we can say maybe you want to buy clothes, you look, or you want to buy shoe, we know the size, we know the price, we know the color. These are the properties. Then objects have behaviors. The shop, put item in the shop, pay. So this is it. The shop itself, put item in the cart, and also to make payment. Those are the behaviors. So to shop means you go to the shop, take and put them into the cart. And then you go to the checkpoint, you check out to make the payment. So those are behaviors. So the physical, why do we say it's a physical? Like a shirt is physical. Conceptual online account, like online accounts, it's not physical because you cannot see an account to say this is the account. That is why you call it conceptual. Conceptual, it's not physical. But when you go to buy shirts, shoes, and the race, those are physical objects. You can see them. But conceptual one are like bank accounts, which you cannot see that this is the account, or maybe you opened a wallet account. So that is also a conceptual. But the wallet itself, we look at it as an object, but not physical. Because when you ask me, show me my account, I cannot show you my account. Yes, I cannot say this is my account because it's not physical. But when you says show me your shirt, and at least you say this is your shirt, and we can see it clearly. So and then the color, this is the color of the shirt and the race light. So I think we have said enough. If we can identify this, so we can begin to write our program happily. Nobody will just be imagining when we say class, when we say object, what do you mean by class? What do you mean by objects? So these are the things. If you are familiar with these terms, we know how to create object, we know how to create class, and we know when we create a class, we mean this. When we create properties, we mean this. So there will be no issue. Okay, so I think I don't want to take much of your time. We stop here. Customer properties and behaviors. So name, address of the customer, order number, customer number, then behavior to shop, set address, add item to cart, ask for a discount. See, so those are behaviors. These are behaviors of customer. See, so ask for a discount, display customer details. Not necessarily for a customer itself, but whatever behavior that is going to happen within the shopping. So set address, who will set the address? Address of the customer. Is when you come to maybe check out, then you now be asked to tell your address, then add item to the cart. Maybe it's the work of the customer, not the seller. Ask for a discount. Who is going to ask this? The customer will ask for a discount. Then display customer details. Who is going to do this? It's not the customer that will display the details, but rather the seller will now display the customer details. So those are the things ideally. So if that is translated, if we look at that from this now, how do we translate this into a Java concept? If we identify that custom properties and behaviors, we say these are properties, these are the behaviors. So how do we now model it into a program? So we say we come here and say public class customer because we are modeling customer. Next is identify the properties. So we now mention what are the properties of the customer, what are the behaviors. So how do we now model this name, address, and this? So we need to know what are the appropriate type to give to the name, address, age, order number, and things like. So when we come here, within this box, we know what to put. It means we need to define the properties of the customer, his name, address, age, whatever, all the necessary things, all details about the customer. And then we now go into the behavior of that customer. All those behaviors are what? Are shop, set address, add item. So we need to also know that this is a method. Okay, how do we define a method? Or what should be the return type? How the method is supposed to be defined? All those setters and getters and whatever will help us. But how do we identify those things? They are not just coming from nowhere. They are coming based on the behavior of that particular object in consideration. So please understand that. So going that way, we have the class customer, and these are the properties defined. The name, which is a string, particularly the customer ID, the address, the order number, and the age. You see, all these are properties which you have defined, and the name of the class is specified here. That is the first thing. That's class declaration. We have declared a class here. Then fields, properties, attributes. Either way, you can call it fields, you can call it properties, you can call it attributes. So all the attributes of the customer are defined here. The next is to what? Define the methods, which is the behavior. One of the methods is called display customer details. So the customer details, then you now display all the details here, the name, customer ID, address, order number, age. You remember when we have that to string method, if you can remember, to string, that display all details about the object. So you can use this to string, or you can say display something. So this is a method that allows us now to define anything you can think of as behavior. As long as it's a behavior, we consider it as a method. But again, Later, we're going to talk about how to create a method, but now we are just giving a general structure, saying that, oh, this is the behavior, this is a method, this how to, but how to define it, we're going to talk about it later. What are the different return type of the method? We're going to define later. What are the different data type? At least I can boldly say I have discussed this during our first class. So we know name is supposed to be a string, and customer ID is supposed to be an integer, then address and the rest like. So basically, so this is the modeling properties using the UML to represent it, the customer properties and the method. So we write it sometime in this. Remember, I talk about feasibility study, design, then implementation, then testing, debugging, like that. So in the first phase, you do the feasibility. When you do the feasibility, that is the feasibility means gathering requirements. You meet the clients, gather requirements, ask them what they want, how they want, everything. Then you now come and model it, identify based on the interaction with the clients. You'll be able to now come up with the possible classes and how the interaction of these classes. So when you do that, then you now go into factoring things that are common and things like, so you identify which one's supposed to be a concrete class, which one's supposed to be a abstract class, and the rest like. But now, since we are not yet there, one thing we emphasize is how do you identify a class? Okay, this is a customer, and the customer is a class. What are the properties of customer? Remember, we are not talking about specific customer here. We are modeling an object customer in general. So when we come to say this is the particular customer, then we now specify your name, your address, your billing info, age, customer number, and order number. That identifies whose customer are we referring to. And then we now consider the possible methods here. So by doing this, we give you an idea of what are the possible classes and the rest like. So if anything is missing, even if you present this to the layman, okay, and tell him that these are properties that we intend to capture about customer. If anything is missing, he will say, oh, sorry, phone number is missing here, and I believe customer is important because whenever there's an issue, we need to call the customer who has purchased our product. So capturing the customer, the phone number will be highly very important. So this will now give us an idea of how you model and what is missing. And then for the different methods, if they know that these are the behaviors, they'll say, oh, no, I can't see where customer can collect loan. Okay, we need to add a loan. Yes, because this is written in English something. So at least one can make sense out of it as long as you tell the client, this is what it means. So if anything is missing here, then it can be highlighted and also added accordingly. So I think these are the data fields. We talk about the properties and the rest like. So I think we stop here. If there is any question, please feel free. If no question, then we stop. I told you that fields, it means the same as properties, the same as attributes, the same as data members. So we can use any of these terminologies. Fields or data fields are official Java terminology. We can say fields or data fields. These are more official in Java terminology. But however, you can call them properties, you can call them attributes, you can call them data members. So if you consult any textbook and they're talking about data members, please don't be confused. They are talking about properties or attributes. And you know, attributes or properties or data fields or data, whatever, they all refers to the name, phone number, email, anything that can be used to identify a particular object is called properties. So Java has particular ways of representing data. Section 3 will take a closer look at the data. We will use the main method for this investigation. For now, it is stretched to include a lot of code in the main method, but a large main method is strongly discouraged. So we don't overwhelm our main methods with so many things, but for now, we go by it. And that's why some of the program we write at the first introductory, we write it within the main method, but eventually that will be separate. So we're not going to overwhelm the main method with so many things because not everything will be in the main method. But when you have it in the main method, it's still fine, but not everything. So that's, I know if I talk about main method, you know what I mean by main method. This is simply the public static void main, this one now. Not everything will be here. Even though we said this is the first entry of Java program, once it comes to execute, it will start from this main. and then reach other places. Like, okay, so I think, guys, we stop here. By tomorrow, we go to this 2, 3. Okay, 2, 4, 3, chapter 3. So chapter 3 is the what we're going to talk about, guys. So which is highly important, which is dealing with how to define all these data type, how to model, write a simple program. So like that. I think this one, if we understand this, so by the time we come tomorrow, we begin to write a code declaring all this. And so I believe nobody will say, what are we doing? Are we doing magic? That is for those who are regularly attending. But for those who are just asked for an account to be created, and I know so many will ask for, please create my account, but not that they have the intention of learning. But if we have 1 or 2 people who are who have the interest to learn, then that is fantastic. But like I said, please don't mind. You can always stop me, ask question. And I believe we're going to be regulated. And that's why I didn't bother myself when people keep sending their email so that the account will be created. I know some will default. So, but with the limited number we have here, I believe even if you stop me and ask question, it won't be an issue. Okay, so any question, guys, before we stop? Is everything understood?
Yes, sir.
Okay.
Yes, sir.
So if everything understood, then we stop. And by tomorrow, we continue with chapter 3 now. So please check on you need to monitor, because by the time you don't log into the Oracle, then they know that an activity is not going on. Because when you log in and open any material there, it will indicate that you have opened this material at this time, at this. So please just log in to show that you take some activities, okay? Because I myself, I can check and see whether you have logged in and when last you log in. So, and eventually only those who are active that will leave their accounts active. Otherwise, I will just deactivate the account because there is no activity going on. So please make sure that you log into the Oracle and read from the material there. Okay?
Okay,
Okay,
sir.
sir. Thank you, sir.
Thank you.
Thank you.
I don't understand which oracle. Sorry, me, I'm just coming for the first time.